The audience in front of the TV audience with you. Hello everyone, I am a teacher Fu Helling. Welcome to watch again Surprised Universe. Today I want to say the subject is called Star Trek. Since we last talked about the sun. Our sun is our patriarch. We live in this interstellar inside. This is called the solar system, but after we have had for a long time. We have to leave the solar system, to go outside solar system, the inside of the process. And what happened in the past made some, what the future will do some. In this episode to give you an introduction, this topic is Star Trek. Next to the imagination through imaginative. You can see that they have a wide range of, including UFO. Star Trek is Jayatanganju. So I have a few content. The first one is inside the Star Trek science fiction, so interstellar travel feasible it. Look inside the Earth in space. 1,000 kilometers from 300 kilometers, 10,000 kilometers, 100,000 kilometers, 100 million km, 1 billion km, even after 1 billion kilometers. Again is the influence of the sun on the Earth. The sun put us in a ball inside the bag. As long as the place where the solar wind, that is, the position of the sun reach, protect us. But how do the sun? What is the impact on our sun is? So we in space inside. Currently the space can. Only a called space shuttle, now that we now reach the farthest boundaries. Where is that? Then we talked about Star Trek. We want to leave our solar system. Beyond the solar system. That began a real Star Trek. First of science fiction and Star Trek. Then we look at this yearning for everyone. The first is the Outer Space 1999. This is a 1975-1976, 1977 of a science fiction movie. This is the British shot. It is the main character actor Landau. That space inside. We have been to the moon 1999. But in the back of the moon, we store a lot of this nuclear waste. One day accidentally explode nuclear waste, a blast, because the explosion will naturally produce thrust. This thrust put the moon out of orbit. So how strain? This is called Space 1999. Then again is 2001. Arthur C. Clarke's Space Odyssey, the science videos yet. 2001 is the year we've had the space station. This is a rotating space station, that we are now with us in 1998. The first was a space station modules into blocks, start the whole complete in 2005-2006. So talk to him almost. A little later point, again is this which talked about the artificial intelligence of the computer. How to deal. Top left, is put a strange stone on the moon. This stone toward Jupiter. Jupiter represents in our guide. Is not want us to look at Jupiter. This activity in the solar system inside. Then in 2001 Space Odyssey, there are a lot of high-tech, some of the effects of the space station spacecraft. Then the inside. This is the middle of Arthur C. Clarke, then next is the director, then follow 2010. Odyssey 2. Is this Space Odyssey 2? Megatron is called Titan. Both films have acted in Taiwan. This video says that we already know the Jupiter. Cooperation with the Soviet Union and the United States. Go into Jupiter. Hope to be able to see Jupiter doing. Because there is a signal, tell us go to Jupiter, then to Jupiter after it. We actually found falters. That cannot go up how to do it. The result was 2 spacecraft. And already damaged so 2 spacecraft into 1, in a call. That is, inside my doctoral thesis, a portion of the data, way is to use atmospheric drag. See above into this Jupiter. Finally, of course, Shayu Airback. That movie is the 2061 Sanbu. Sorry this video is not a movie, because the cost is too high, so far there is no. Then this movie is over there. Is again a rendezvous with Rama. This is Arthur Clarke, he said. In which there is already a star. A lot of things to do Star Trek. The Star Trek. On our planet, found a very big one. Like pillars thing called Rama. We want to see this Rama. We sent a spacecraft to see. We recently discovered to this with this meteorite is almost cylindrical. Well, this movie is to tell you. In this rendezvous with Rama inside to see. Is a man-made alien city. Well, we finished talking about this. Star Trek feasible it. Well then we have a few. The first environment you promised not to permit, up to now in terms of the environment is not licensed. Why have a strong radiation? Generally, we like astronauts back into space. Most eyes have cataracts. And this body. Osteoporosis has a problem. There is no way to bear the body. Technology has reached yet. The chemical rocket. We are still stuck in chemical rocket stage, so we can only go there in the solar system. It may not be feasible outside the solar system. There are still some distance. The human body, the human flight. Star Trek has been done yet. There is Voyager. Wait a minute, I want to say Voyager 1 number 2. So to avoid the risk of accidents this is to avoid this dangerous accident. Therefore, the United States carried out a lot. Biological organisms, cabin compartment number 1 number 2. Mainland China also. Hope in. About 2 to 3 years inside. Housed individually inside a room. Look at this body. Under lonely circumstances, some changes. We now look good. We left the Earth from space Earth. It is 300 kilometers outside to see Earth, that this is my satellite on. We all know that if my first escape velocity, 7.9 kilometers per second, we can launch a satellite. Above the Earth. It is 300 kilometers satellites. Look, Earth is like this. This is Apollo 8, before landing on the moon yet. It did surround a moon. Look at 380,000 kilometers outside Earth. You look like a blue marble. Like a marble as. This one is Apollo 11, has landed in the moon. On the moon they took a picture. It is similar with just. But distance is not the same angle. This one is the Cassini. Cassini is Saturn probe spacecraft. Number 15 September 2017. Friday into Saturn's atmosphere. Self-destroyed before it took a picture. This is. On the left to see the bigger is our planet. The right to see that the moon is relatively small. Earth with moon. Both appear in. The final scene on Cassini. This one is January 31st, 2014. Curiosity on Mars photographed Earth. That little arrow to look carefully. There is a white spot that is Earth. See the Earth in 529 Martian days to go. Then the distance is now very, very far. But do not forget far enough. This one is very far. This is our Voyager 1. February 14th, 1990. After the big cruise. Before going out of the solar system. From 6 billion kilometers away in space looking back at Earth. My blue arrow. In that one. Brown band intermediate, a white spot at. There is a small white dots. 3.7 billion miles, about 6 billion kilometers away. See the white dots. This is what we are ever. The farthest to see the Earth. That is, if we interstellar travel. To the edge of the solar system. We look back at the Earth. That's just like a tiny white dots. But this white point but gave birth to life. They break out above the man-made objects. So took a picture. Looking back at their home. I put this to enlarge. This is a very monumental photograph. Voyager February 1st, 1990. One navigator to see home. Talked about the inside. We have been living in. Bubble inside the sun. The bubble of the sun. Impact on the planet. So I wrote back. It is 60 kilometers. To 140 kilometers of aurora. We can see. Last time I talked about above intermediate. Aurora is because the sun's flares. The sun's surface. Coronal mass ejection. Hit Earth. With the Earth's magnetic field is generated. This is a very beautiful aurora. Aurora each way. Then good. This is our space tools. Our space is a tool that the Soviet Union. Top left Russia before storm. But then because Russia. The disintegration of the Soviet Union became Russia. They did not so much money. Funds to pay for this space. So then it is cut off. So the bottom left is the next generation of possible. Similar like X-37B space shuttle. The right is. This is the future might look like a space shuttle. Why then the shuttle will stop it? The main funding is too high. The second it too dangerous. Two of the biggest risk. This is America. January 28, 1986. Space Shuttle Challenger explosion. When the explosion T plus 71.8 seconds. Because of the relationship, on the left you can see the highlights. The highlight of the display it inside-out rocket. Flame retardant is one that has a rubber band embrittlement. Because the temperature is too low emission, then the cause of all 7 astronauts died. The second time was February 1st, 2003. Number of unexpected deaths in Colombia. On the left you can see the left side of the first figure. It is in this Jiaju this. There are shells above a space shuttle foam. This foam is a thermal insulation. The thermal insulation fell off. Hit the left side of the shuttle wings. Outside of the outer third of the wing. It caused a hole. But why did not see it? For a start, the space shuttle has been up and running. Air resistance is getting smaller. Almost no resistance, so there is no impact. It is little space inside air, so it's hot little impact. But once back when I'm sorry. Thermal getting bigger, leading to the heat from the inside filling inside. Blow up the entire wings are split. Well, this bottom photo. This is the space shuttle. The right is the first generation of space shuttle. That the second and third generation space shuttle is look something like this. We do not know, but the whole world in research. The whole world study. I just say the left is the number of storms. Russia is. Well, then we talked about the space shuttle, now speak. Currently modern technology, there is a X-43B. X-43B airport in the United States. Within less than 2 hours, it can cover any airport worldwide. This is the technology by 2010. But in 2010, after. Now there is a X-51. X-51 it does test flight in May 1st, 2013, can reach Mach 5. It is at a height of 70,000 feet. It can too. That is the height of 21,000 meters. It can reach Mach 5. What kind of data is Mach 5? That can go 3,300 miles per hour. Or take the 5,300 kilometers per hour. So here are they predict. Scientists predict that within 20 years, at an altitude of 100,000 feet. 100,000 feet. The future is probably even more than 3 times. Speed can reach 3,750 miles. Then this is the space shuttle. The latest development of technology. Well, this one is X-51 on the right. Is the latest US. But it is only in the air. Performed less than 10 minutes. It's an automatic device to burn off a hole, not yet able to fly throughout the complete. So the science of technology. To break through the current situation still. It is a left. If it can be commercialized once the breakthrough, then we can see that. Scientific achievements of our planet. This is the last of the Apollo 17, December 19, 1972, the last figure of the moon landing. That is the circle of lunar rover. To the right is the spacecraft back to Earth. That followed Mars probe. Mars probe. This is 2004, Mars. Spirit with Curiosity. Passed down some pictures. Now we will talk about one of the themes. Where mankind is reaching the farthest territory. This is a bubble. This is a sun as a ball. The middle is the sun. Sun, solar, wind are able to place. Protect the entire solar system. The formation of a bubble. The ball does. Top right is the Voyager 1. Below is the Voyager 2. Voyager 1 first Jupiter. And then goes out. Voyager 2 except Jupiter. It took us to see a whole other planet. Now fly out. That middle there is Pioneer. Pioneer number 1 with number 2. Pioneer Tenet. This communication has been interrupted throughout. Herald number 11 in the middle of the left. Currently not working. Now is the Voyager 1, Voyager 2. 2 still flying. This one is about me before 2010. IJPL. Then attend a seminar, real photographs. Scientists later after talking with them. I took on the inside. I was in this Voyager 1. Take a picture. Why I took this picture it, followed by a, you do not look this one. This is a blonde woman, this woman scientist. Very great. Then she was very happy with my photo. I am willing to. So I took this photo on photo down. We can see the top of our. That is, Voyager 1's. High gain antennas. It is to be in front of the Earth, 3.75 m antenna. Then go out on the edge of the Okanagan. There are 3 meters long. That is, it's a type of extension. The entire structure of about 3 m. The antenna on 3.7 m. So shine over our heads there is a circle. Then tell everyone. The Voyager's size. This entity Voyager. Voyager is so big so big. The middle is high gain antennas. The first step we take a look at Voyager 1. It was launched in 1977. On our planet. See what kind of things. We now put the movie. The first portion Voyager 1. Taking off on August 20th, 1977. Well, first of all it in 1979 August 1st. After this it's slowly in space inside. High gain antennas white. See Jupiter aligned with the Earth. This is from January to July to see Jupiter. Note. You pay attention to the lower left of Jupiter's great red spot. This is a black and white film, because there was no digital video. Analogical. So first. The analogy is very clear benefits, but the drawback is that the resolution. You see there is no black and white color. It has something to run out. This means that it is a powerful storm. Solar storm. Immediately we see that one of its satellite Io. Io, Yeovil Town, this satellite. You can see it in the gas ring. Then Europa, Europa. This is the Ganymede Europa. This is Ganymede, GE feet Metai. These are its satellite Callisto. These are its satellite. Why is it depends on several satellite, that there may have several satellite. There may be some life. Directly reached Saturn in 1980 and 1981. Note the 7 rings of Saturn. Next to the white. Is that all satellites walk around it? Walk around it. Then the shadow caused by this ring inside, lap 2 laps 3 times, can clearly be seen. Those actions inside the ring. There may be some fragments of what? Then we see. Mimas Saturn's rings. Titan is that it? Saturn is probably the most famous living. Huygens landed on top. Then we see the so-called February 86. We saw Uranus. Notice that Uranus. November 1986 to February 1986. This is the moons of Uranus. Miranda. It noted that the above is not like Pluto, one of the frozen ice. Then cut out of the ice gorge. Then it reaches Neptune blue. Neptune October 1989. We can see this Neptune. It also has a red dot. There is a large black spot. This black spot may also be similar to this storm. And traces of other so-called frozen. Then we look at its Triton. Neptune satellites. This is generally not C. UC is not very similar to Pluto. So why was it removed Pluto? Mainly because it almost looks related with satellite, so it did not become a planet. It followed a good antenna alignment Earth. February 14, 1990. Looking back at the Earth took precious photos. Look at what we just photos. It only take this Uranus. Then take this Saturn. Then take. It is February 14, 1990. Beat back all parts of the movie. Here is Venus, Earth. And Jupiter. After it looked back then transferred corner. Then began to leave the solar system. Into the sheath day. Then enter interstellar travel. This is the last page into Star Trek. Star Trek start. The first human planet. The first spacecraft to enter interstellar travel. From this picture you can see it too. Voyager 1 with Voyager 2. Voyager 1 from below to go. Voyager 2 away from above. That go from the top of it. It is in 1989 August 24th. Arrived at the Neptune. After the first Uranus. And then reached Neptune, just like the movie just as described. Then took a lot of precious photos. Well, this one is yesterday we took. So far. In late February this was instant. Instant its status. It's time to launch. 42 years it is now 42 years old. You look about 43 years old, 42 years old and a half. 42 years and 5 months. Going to the 43-year-old. Here it is then the distance from Earth. We can see very clearly. Its bottom is then radiation. You see it's a much longer pull radiation, so human beings in such a long period of 43 years, you want to be able to withstand so much cumulative radiation. Is it possible? This is an issue of Star Trek. It has helped us have a good measure. Well, this is its speed inside. We look. Speed of sound. We take a look at the speed of sound. About 0.34 kilometers per second. If Concorde. The first commercial airliner Concorde STS. Supersonic speed, it would be just double the 0.6 kilometers per second. A bullet. Slightly faster than the Concorde. 0.76 kilometers per second. This is a breakthrough in the speed of sound only, not several times the speed of sound. Below this is Voyager 1. It leaves the solar system. We humans is currently leaving the fastest speed of the solar system. Is 17.2 kilometers per second. That is the third escape velocity. Is probably about 16 kilometers. The first escape velocity of 7.9 kilometers per second, caused by Earth satellite. The second escape velocity, leave the Earth into the solar system. Probably 10 kilometers per second, just go inside the solar system. The third is to leave the solar system escape velocity. Probably as long as more than 16 kilometers per second, they can leave the solar system. It is 17.2 kilometers. It is currently on Earth. The fastest speed can be created. This picture tell you now Voyager. We have entered into this interstellar inside. Which device is off? Notice you see Voyager 1. Because Google is turning travelers. In fact, I was turned navigator. Voyager 1, Voyager 2. Voyager 1 is only the top 4 things. Is open on. All others are turned off. Why is not enough? Because power, it is only about 470 watts. 470 watts for 43 years. 3 plutonium Pu. With thermoelectric plutonium digit. What's at power 470? That right is Voyager 2. Voyager 2. 1, 2, 3, 4, 5. It has 5 things on. The following are the relevant. So Voyager 2 compared live a little longer. 2 are launched in the same year. Up to now all 42 years old. It estimated that by around 2025. In fact, in 2020, its power has estimated almost. But this is strange. It is forecast to reach 2036. So before 2036, the above 4, 5 will slowly turn off by the time it becomes a wandering interstellar travel. If any aliens picked up, there are a lot of things above. No, this is from 43 years. Several years ago, the Earth is from our point of view. That will give us a response. This is it. Voyager 1, Voyager 2. Leave the ball out. Reach out interstellar. Protected from the sun. So it is a sudden increase in cosmic rays. So when cosmic rays, sudden change of time, Japan says it has left the sheath, out of the solar system. That this is even more clear. Voyager 1, Voyager 2. You see interstellar wind constantly blowing in. The bubble this sun ball played a role in blocking the whole of the bad things. The use of solar wind. A blocking barrier is formed on the outside. The whole solar system a little more harmonious. It is now left. I'm sorry, there is no way to protect it. Well, now I probably soon to talk about. 37 years ago, the computer was 160 bits per second. 37 years ago, the longer the. What about now? A 110 million. 1 million bits per second. How much worse? A billion times worse. 10. Nearly 100-fold difference. Probably more than 100 times. Many times more than 100 times, 10,000 times. Then following its memory cards. Also 14.7 times more than before. It is everything we like. An iPhone 6. iPhone 6 to 16 gigabits. Then what? Voyager 1. I'm sorry, it is K-class memory. We are the G-class, also a lot worse times. It is indicated in the past 43 years of technology. With today's technology cannot be compared. But it is now 43 years of technology. It has been able to do a Star Trek. Okay, this is its achievement. First seen in 1979, the Great Red Spot. Then it. Seeing the rings of Saturn in 1980. See its Enceladus. It's most interesting. The satellite may be above water. Titan II satellites are 1 million kilometers outside to sea. This is then seen Uranus. Saying the satellite Mirando. This we just let go. Again is Neptune. Triton its Antarctic ice cap. Finally, I also came alive again in a photo. February 14, 1990. Finally, a look back to Earth. Then see Saturn's South Pole storm. Okay, so now I'm going to talk about. Then we went to Star Trek. Extrasolar. Mankind's nearest neighbor is what some of. We look. This is a bottom sun. If we look at light years. 2.1 light years. Nothing out of 2.1 light years. But when the 4 light years away, last time I used this picture, is Proxima Centauri, the right of the red. We now assume that our goal now is to Proxima Centauri. We assume that this is Proxima Centauri. Proxima Centauri is only 4.2 light years, that there are many, many outside this. Is that many of those habitable planets? Is 4.2 light years? Do not know. This is the closest. But the United States now have a plan. We look. This is a 2008 Kepler spacecraft to detect Earth-like planets. There is no similar planet Earth with it. Inside the solar system, in addition to those habitable Venus, in addition to Mars with us. Almost none of those habitable, but Venus, Mars damaged. Only now the only planet, that other solar systems with other galaxies inside, is not at also like this. So for the first time in 2008, Kepler satellite to play up. Technology means that we have been able to see Earth-like planets outside. Now this is 2008 note. It is 2020. Last 2 years ago, United States implemented a terrestrial planet finder. Terrestrial Planet Finder. TPF. This is the United States to further launch high-tech satellite view exoplanets. This is the satellite TESS. This long-way spacecraft, the opposite of that white, is a star. Next to the stars is a planet. It has to come to this planet. The planet Earth almost like Big Hope. Jupiter does not exceed the maximum, in the middle of the planet Earth and Jupiter. So good this year, January 7, 2020. NASA Planet Hunters announced a message. The first habitable planet outside the area. D has a back TOI 700D. This is a 101.4 light-years away. We have just seen is Proxima Centauri, is 4.2 light-years. It is Proxima Centauri is almost 2.5 times bigger. A dwarf 101.4 light-years away. What does this dwarf star located? Dorado is a constellation Dorado. Inside the south. That it is a planet in habitable zone. The first water. The second temperature is just right. About the size of Earth. 3 conditions are satisfied. Then this planet. After NASA Spitzer Space Telescope confirmed that indeed there is such a planet. So now publication no, January 7th. So where is this place? I have to show you this picture. If we take the astrological chart, to the south side are the stars. Notice the bottom left below the stars of the south. Is there a Dorado? Is there a Dorado? The Dorado is the planet where Doradus. Then this TOI 700 dwarfs. This is a very cool dwarf star. Middle notes that this is a. It dwarfs right. It can emit energy that is a star. It is similar to our sun, but smaller than our sun. This has then B has C. This is not suitable for living. It turns out that only the most livable D. So probably at 101.4 light-years. LY light-year is light-years out. It used the inside. I am prepared to look at a movie. Test project. Is NASA's test. What is to explore the outer planets using the method? Transiting use occultation. A planet to the star's light cover. The light. If the cover of the planet, the greater light on the more planet smaller cover the less light. Using this theory to detect extraterrestrial habitable zone of the Earth-like planets. We now see the movie Dear Boo. The good Earth-like planets. Earth is like a long way. Well, this Earth-like planets that test. The latest U.S. technology. Survey satellite. NASA's latest satellite. Then this is a masterpiece of MIT. This is a NASA space this. The astrophysics scientist. Women scientists introduced. This is after a Kepler. With Kepler based. This developed out of a spaceship. So it is hoped. Can influence the brightest stars. Able to find. Neighbor inside which a planet similar to Earth. Bright planets like Earth star. Well, this is a 2-year investigation. This can be seen. With almost Earth. Jupiter does not exceed the maximum. This so-called giant planets. See no wound. The occultation of stars around it note. Look forward to that light which slowly, light down to the card. If you have the greater fall deeper, the smaller the less it out too. Well, you see this is not a small C. Out relatively small, with this out of the shade. The star in the end to determine how much. That this thing is basically. Do you see it? You can see 24 degrees 1.68 million pixels, 1.68 million pixels. There is this range of 24 degrees. But it has 4 cameras. 4 by 24 96 degrees 360 degrees throughout the space. It can be seen that a quadrant. Scientists hold. Kepler than the previous. Big effect 350 times. Kepler in 2008 than in the past. It is its 1/350, then C. Basically it was observed 27 days. Is rotated to the next galaxy. C4 coordinates. This is a look at the coordinates. 27 days to another coordinate. The entire circle. Noted that the entire southern hemisphere's celestial sphere. Then the whole of the northern hemisphere celestial sphere. The whole sky all included in it. This is seen in the whole of the area it sees. Although not cover the entire universe. But it has been able to see. Kepler saw a little bit of. But it does this Kepler 2K2. It's a lot more to see his sun. It is to take an elliptical orbit. This elliptical orbit inside. Use change track. See it absorbed the entire planet luminosity. Then the elliptical orbit. It is to go around, when the edge of the oval is coming soon. Traveled equal distances. But the time spent on it faster. Do you see it? Southern Hemisphere, Northern Hemisphere planet, throughout the entire sweep over the sky. What came to Earth-like planets? That's what it basically find out. This is James Webb. The future is with James Webb. This is part of an optical, the other part of the spectrum, James Webb used to do with saying, look at its planet. Do mutual authentication. Spitzers now just use, like space telescope. Then take a look. There is hydrogen, oxygen, ammonia. There helium, methane, water. In the end, it is the number of components. In addition, people are not able to live outside. They're minerals. After the man passed. Star Trek to the other side. We can how to. Later resided. It can detect local mineral. To live. Become a second Earth. This is probably the way habitables. This is the scientist explains. The planet's habitability. What it may have similar characteristics. Well, you just look at this. I just talked about this technology, the TESS. The discovery of Earth-like planet satellites. Basically, it does not know how many times stronger than Kepler. It can watch at 370 times things. And there are nearly 2 million pixels. Although we say, we are now tens of millions of pixels camera. Do not forget our tens of millions of coefficients. You cannot anti-shake. As we all know, you want to better the resolution of the camera as long as a very sensitive to jitter slightly. I'm sorry you're out of focus to. You see in space inside. It is capable of 168 million pixels. Also can illuminate so clear. To discover exoplanets. So technology. At the current technology. With 43 years ago. Voyager of technology. But has not been able to be on the same day. Now I want to say a good. Star Trek is the beginning. Star Trek include 4 parts. The first, called near Earth orbit, is called low Earth orbiting. That is around the Earth. This is our first step. Its orbital velocity, basically 7.9 kilometers per second, can be reached. Travel within the second solar system. Interplanetary travel. This is basically a walk in the solar system inside. So long as you have this, 10 kilometers per second, you can leave the Earth into the solar system. So basically go inside the solar system. That both our spaceship basically able cover the. So with 1-2 we have done. The second of it. We now see, say Jupiter spacecraft, and look at the whole. Pluto, Neptune all have seen. Again is Star Trek. The Voyager also saw Navigator. Now is called intergalactic travel. At present we cannot do this. That I just talked about this. Some of our galaxy, in which position in any place, that this is Earth-like planets. This is called Proxima Centauri. Proxima Centauri. The scientists, including American scientists, are now using Proxima Centauri. Make a baseline. There is a basic position. 4.36 light years. Proxima Centauri to 70,006 years. This is based on our technology. This is based on our technology. Then we look at. With our vision of the Earth. Our spacecraft will look like child. Earth Eye. I specifically noted the back. The first speed bottleneck. I just talked about. The first nuclear rocket. The second antimatter rocket. The third laser sail. The laser hit the sails on. With this weak power to drive the laser light sail. Because in space inside, hung jing jing hu. Actors do constant uniform motion in a straight line. The final step is nuclear rammed jet engine. This is currently both in terms of science fiction. Future spacecraft looks like this. Well, I'm here to tell you I have 2 tables. The way forward. We use traditional rocket. Basically, it will be limited inertia. About 5 meters per second. This is about 7.9 kilometers per second parking. Then the fastest. I just talked about 17 kilometers per second. Then again it fission rocket. Fission rocket. Continental is called nuclear fission. Then this is probably every second. About 12,000 kilometers. If nuclear fusion is the sun. The sun is currently fusion. You put the sun. The integration of the above principle is used in rocket. You can reach the speed of 10%. But this there are most critical bottleneck. You neutron nuclear fusion that ran out. How can you prevent neutrons? Do not run outside. Another change is generated. So you want a neutron barrier. What was the best thing blocking neutron? Called helium-3. For now, this helium-3 on the moon. So why should the United States in 2024 want to land on the moon? The first one I think it is absolutely to helium-3. It can start doing research nuclear fusion. MIT professor has told. 50 years within 15 to 50 years. Basically, this technology should be commercialized. That again is a non-reaction force. Note that this inside it. This relatively little controversy. But we are in terms of scientific theory. now possible. The future is not necessarily impossible, father of American Goddard space science say. This illusion is achieved yesterday today. Yesterday's science fiction is, today will be possible to achieve a non-inertial reaction force is not subject to restrictions that we force. There have inertia mass. There must be subjected to the inertia of the inertia control, so we see UFO. You have to right angle turn, it will not turn you. You have to turn the aircraft past. Be sure to pour a bank angle can turn. This is the effect of inertia. The inside there are three. The first is called the warp drive. We called the warp forward. This is called the mobile space and time. It was noted. We recently discovered a black hole right. Black hole we called the mirror of the world. That you will be sucked within the mirror. Not sucked outside mirror, so that this will bend the light across. Gravitational field will bend. The space-time use change. So in other words, say we. We do know that aviation wind tunnel experiment. In our experiments, when we do not have the speed, not the aircraft speed, was added to Mach 5, right? But we can put the aircraft parked on the other side, generating opposing airflow Mach 5. This is the same reason. We moved in space. We can move aircraft production rate. But we can. Aircraft do not move the use of space to move. This is called the warp forward. But the problem which involves a considerable number. The United States did not publish the results it done. Again is anti-gravity. Anti-gravity is what we now call UFO. But we cannot do on Earth. Finally, wormholes. The last one is the wormhole. I wait special presentation. If this is what we use to Proxima Centauri example, Star Trek way. First we used chemical rockets. Its speed 10 kilometers per second. If this rate of 10 kilometers per second, of course, our Voyager, can you see? 17 kilometers per second. Probably more than double. 10 kilometers per second. To reach Proxima Centauri. A 110 million to 12 million years. Okay, chemical rocket. If you use the nuclear fusion rockets, you can speed. Raise to 10 times the speed of light. So how about 44 years? If you can reach 10 times. 1 in 10 speed of light is 0.1. 1 in 10 speed of light. 44 years to neighboring stars, if you make use of antimatter rocket. So it can produce 50% of the speed of light. Half the speed of light, half the speed of light. So the speed of light 0.8. So if 0.8 is the speed of light, can be reached in 3.3 years. In my lifetime it can reach Proxima Centauri, and back and forth 3.3 by 6.6 years. If you run out of cells. 10% speed of light also 44 years. If you use an artificial black hole. 10% speed of light 44 years. Finally, if warp forward. So this is a very special. I noted back. This thing is the energy it needs. If you say that we. Right now we. On our planet. Energy consumption throughout the world 1,000,000 times. Push it once is enough. Push it once is enough. Well, this is only in this Star Trek. Star Trek visible inside. The Enterprise is the use of warp forward to generate good. Well, this inside me about the speed bottleneck. I talked about this 17.2 kilometers per second. This is Voyager's speed. So first at mitotic rate. 0.6% times the speed of light. This is next to all nuclear energy. Then play up. Until now, no success. The second fusion, nuclear fusion. No more success. Its speed is slightly faster. 12% speed of light looks like this. Nuclear fusion technology next to it, that you use helium-3. Next to the Saturn V. We compare how much you watch. So much quality to hit space. The current terms of science and technology, still a little bit far away. Then again antimatter. Our antimatter this. Our academician Samuel Ting Ding Yuancher. On the use of space shuttle above to detect antimatter. Up to now have not seen the results announced. If you can find antimatter, it can reach 66% of the speed of light, fast, then you can reach 80% of the speed of light. Basically the whole time will slow down. Therefore, it is faster to reach Proxima Centauri, but the current situation is futile. This is the antimatter rocket. Looks like this. Well, this light sail solar sail rocket, that looks like this. Then look here what it light sail rocket. It's that moment below the blue. Go in the moment. Then to the moment of reflection. It's two seek together. That is below the red line. Then on top of that red line, it is the reaction of direction. This is entirely consistent with the principles of mechanics. Of course, also very slow. This is the art of scientists in conjunction with scientists. Painting light sail. Push forward the way the entire spacecraft. This is with a laser. Here a lot of laser light to play up focus. Hit the fan. with this sail to generate power. Laser light on the type of sail spacecraft. This is the wormhole. I'll be there this primer. I say this as the next content. The wormhole, notice it's red. This theory was first proposed in 1921. So that is the wormhole. Wormhole itself is a channel space. In theory, can pass through the hole. Like we said, two pieces of paper. For example, say I have here a piece of paper. We can see that I have a piece of paper, right? I have to check this. I now stick with this point of this paper. I want to break up. I want this to fold up. How do I fold it? Then go through here. Is not pass through, but I and there are a prerequisite. Notice. Directed this remake point. Bottom. This you have to be someone open this hole for you. You can go. We humans to the current situation is, there is no way to open this hole. So if advanced civilization, it can give you this hole to open. Tell you please come in. You can go. The inside. The United States has a plan in 1964. In 1964, the United States has a program called SERPO, SERPO. Interstellar Communication Between Humans and Aliens Plan. This is in addition to 38.4 light years. 38.4 light years. We just look at that picture, where is it? Notice. This is not below it, Dorado. Doradus 101 light years it right. There is a top right above their reticulum. It is interesting. I have this very interesting for everyone to see. Reticulum is in the constellation Dorado. Slightly above the point, still relatively close to 38.4 light years. Doradus now exoplanets found too. There are Earth-like planet in the habitable zone. Is 101 light years is 3 times. Note that in this planet. Reticulum where a planet. We look at the southern sky. So say what representation expressed that this is the. Is not that we have. Star Trek doing of it. Finally, I want to say a few words. Humans need to fly it. 19th century Russian astronomers. Phasios Stokowski, we humans. Does not live in the cradle forever. Be careful of piercing the atmosphere at the beginning, then to conquer the solar system. Today, the space shuttle has been out of the atmosphere. Future space station will be modeled. Space shuttle as a tool, more into the sky outside. Basically. This last sentence. Earth is a spaceship. We are riding on this Earth. Sailing in the universe inside. Fly galaxy. Fly to places unknown future. Thank you for watching the next meeting.